Hello everyone, welcome to our presentation. This is the name of the project is FutureFit and this is CSE427 group presentation and we are group number 12. The team members are Habibur Nobi Himel and myself Ishaq Hamim Bahi. The agenda of our presentation is on the screen, so let's start with the introduction. So I am a third year university student and I myself worry a lot that how much salary am I gonna get after graduation. So I believe that a lot of students think like that, so we have tried to solve the problem with machine learning. We have trained our model with this kind of placement prediction data and our model is performing very well, and after that we have deployed the model so that users can get benefit from it. So diving into the dataset description, the dataset is a synthetic dataset because we could not find any sufficient dataset with sufficient amount of data. So we have picked the synthetic dataset with 2,20,000 rows and 19 columns. And also no work has been done with this particular dataset before. So we're the first group doing this kind of work with this particular dataset. And the usability score of the dataset is more than 8. And also there are enough room for data pre-processing. So we know that in our project there was a task to pre-process the data, and this dataset satisfies that that requirement as well. Also, the target variable of the dataset was placement package, and this was a continuous value, meaning that as we were told to do a classification task, but it was a continuous value. So we had to convert this into a classification task, which we'll discuss thoroughly about in the hands-on demonstration part. So the literature review, we have gone through several papers, and after going through several papers, we have seen that many of the researchers have tried to solve the problem, but they haven't trained their model with this amount of data like we did. And also in the papers they have used several machine learning and neural network models. Among the models, random forest and logistic regression worked best, and in most of the cases we also have a heuristic that in our case as well, like random forest and logistic regression might work the best. Also, none of the workings included any GUI implementation, so we have also worked on that part. We have hosted the best model we got and in a GUI platform so that users can get benefit from it. So passing the floor to Habib Nabi Himel.
Thanks to Ishak. Now I will cover the methodology part. We have followed 4 steps to prepare the whole project. Start with the area part. Exploring data analysis. So first of all, we have analysis the data set thoroughly in order to gain useful insights. In this part, we try to get the knowledge about the features in our data set. We have seen that in our dataset there are the features which contains categorical and numerical values. We can generate idea of we need to do label encoding or on-hot coding. We will talk about this in the data processing part. Then we have also generated the correlationship matrix, which give us the information that how the features are interrelated to one another. Now it's all about the data processing part. In this part, we have mentioned that we started with 2,20,000 row and 19 features. So we drop the duplicate and null values because this type of things will not do any kind of contribution in the model training. Then after that, we figure out which features will be useful for us. Then after that, we also make the dataset as it can help the models to train more efficiently. Then after that, in the model training part, as my teammate said, that we have a heuristic idea that random forest and logistic regression can perform well. So we pick six
models.
Models like random forest, decision tree, logistic regression, and other KNN and other models. After that, basically we imported them from the sklearn and directly use them. After that, after we get the knowledge about the base model like random forest, so we set it and host in the cloud. So if you can see in the bar chart, we can see that almost every model performs so well with good accuracy. But if you deep down into that or look precisely, then you can find the random forest and decision tree perform so well it exit the limit of 80%. So which is good. On the other hand, the logistic regression and naive bias, so they did not perform like the random forest, but it also good to run. Then after that, in the conclusion part, as we mentioned that our project is doing perfectly well to predict the outputs, but we believe that there is a room of improvement still open. In that, in our future, where we can use neural networks and other logistic regression based SML algorithm. And the most interesting part, the GUI part. Now we will start with the demonstration part. Thank you for that. And now it will
So let's dive down into the GUI part. So we have deployed our model in Streamlit platform, and you can see that the So you can see that this is our model, as this is our web app, and this is a very beautiful UI. So if we fill up the questions for saving time, we have filled it up earlier, and if we just click on predict percentage, it that's great. So because if your percentage is higher than 20 LPA, then it will be classified as great. So you can see that there are conditions like this, and if users like put their data, the model can accurately predict their possible placement package. So if we go through the data set, we can see that this is the data set we have taken here from like Kaggle. And after that, if we like go to the overleaf part, so this is the LaTeX file. So passing floor to Himel.
Okay, so now we will cover the paperwork and the backend part. After that, we will cover the backend part. So it is nothing to say about this because it is all about the lattice command to generate the. We try to follow the double column ICP format. Here you can, if you want to see about our paperwork, then it will start with the title, then the author name, then we cover all the necessary things like abstract, introduction. In the introduction part, we subcategorize by telling that architecture diagram and sample data set. In this part, we mention the what actually we have done thoroughly to visualize for the users, like the data set collecting, processing, and every other things. Then after that, in this part, we give a summary of the literature review. Then we started the methodology part where we also discuss about the data processing part, and we also give some brief idea about our models like advantages, disadvantages, and a summary of that. So in that analysis part, we focused on random forest because it's our base model and we have set it to deploy in cloud. So here we, if you want to deep down, so we can see the F1 square precision recall. So get an idea of the false negative to positive, this type of things which help us to know about our model more precisely. Then in the last part we added the conclusion part where we basically summarize the whole paper and it's the reference part. Now if we want to go to the core part, which is the most important part. So firstly you can see that in this part we imported the things, then some ideas about our dataset. Like you can see there is a 19 column where all the features are mentioned. Like if you see the name of number, roll numbers, the interview room temperature, these are the features which will not contribute much in our model, so we drop them in later. In this EDA part, you can have some idea that what actually our dataset looks like. Okay, so here you can see the categorical values and numerical values. As I mentioned that we need the numerical values only, so there is the time we need to do some kind of encoding. First we tried with one-hot coding, which give a problem like it increase the dimension. So we ended up with do some level encoding. Then you can see in our dataset, like in our features, the instances are evenly distributed. Why it happens actually? Because of we use the synthetic dataset, that's why the numbers are evenly distributed. So that's why the 50-50 are happening there. So after that, if I want to share about the data processing part here, we drop the unnecessary useless features. Then after that, we drop the duplicate values. Then we also drop the null values. Then after that, finally, we ended up with the number of data 1,80,000 and the third feature. Then we start our work. So in that part, we can see the correlationship metric where we can find that CGPA has the more correlationship with our output. So that's what we can see after watching the correlation metric. Now I will pass the floor again to Isha.
So implementing the models, we have like I splitted the data into 70-30 split training and testing ratio, and after that we have like set up thresholds. So we have told you earlier that the value was continuous value of the target variable. We have converted into a classification task by poor, decent, and great classifications, and after that like we have seen the distribution, and after that we have trained decision tree random forest one by one, and we have imported the model from scikit-learn and then trained. So this is 84% accuracy, and this is like the confusion matrix. So random forest works the best for us, and after that we have saved random forest model in using the pickle library, and after that we have saved the model and deployed the model in the web. So this is the GitHub repository. Anyone can, this is a public repository, anyone can access it, and we have used Streamlit as for coding the web app and also the hosting platform. So this is the platform and anyone can access in this URL. So this was all from us. Hope you had a great time with us and hope you will try our product and predict your future. Thank you.